Good morning. Welcome to the 17th International Conference on Applied Human Factors and Ergonomics, AHFE 2026, and the affiliated conferences at Fenerbahce University, Istanbul, Turkey. In this tutorial on AI-DUXU, adaptive ergonomics, UX, and the usability in the age of AI, our objective is to explore the integration of ergonomics principles in UX UI designed to enhance user comfort, reduce errors, and increase satisfaction. Get ready to learn, engage, and enhance your design skills. The digital experience challenge. Digital technology has become embedded in nearly every aspect of modern life. People regularly interact with online banking systems, e-commerce platforms, healthcare applications, educational technologies, and social media environments. As reliance on digital systems increase, expectations regarding usability and convenience continue to rise. The role of UI, UX, and ergonomics. UX, UI, and ergonomics address different aspects of the interaction between humans and technologies. UX focuses on the overall experience, UI focuses on the visual and interactive elements, and ergonomics examine how systems align with human physical and cognitive capabilities. Together, these disciplines create a comprehensive framework for user-centered design. Why this topic matter? Organizations increasingly recognize that usability is not merely a design concern, but also a strategic business consideration. Products that reduces effect and improve task completion often achieve greater customer satisfaction and stronger competitive advantage. Learning outcomes. The tutorial moves from foundational concept toward practical application. You will examine theoretical principles, analyze real-world examples, and explore methods for creating more accessible and effective digital products. Why UI UX matters in modern digital products. Rising user expectations. Modern users compare experiences across different products rather than within a single industry. The convenience offered by a leading platform shapes expectation for all digital interactions. As a result, organization faces increasing pressure to provide innovative and functionless experiences. Consequence of poor design. Poor design introduces obstacle between user and their goals. User may struggle to locate information, understand functionality, or complete important tasks. These challenges often generate frustration and reduce confidence in the system. Organizational and business impact. Usability influences operational efficiency as well as customer satisfaction. Better design systems reduce training requirements, decrease support requests, and improve overall productivity. The financial impact of usability therefore extends far beyond aesthetics. Comparative advantage. As functionality becomes easier to replicate, user experience increasingly serves as a source of differentiations. Organizations that invest in human-centered design frequently achieve stronger user adoption and great longer-term loyalty. UX as the complete user journey. User experience encompasses every interaction that occurs between a person and a system. This perspective recognizes that users evaluate products based on the entire journey rather than in isolated screen or features. Every stage contributes to overall perceptions. Beyond visual appearance, a visually interactive interface does not automatically create a positive experience. Users often prioritize effectiveness and ease of use over aesthetics. UX therefore examines both functional and emotional aspects of interaction. Core dimension of UX: usability, efficiency, accessibility, and the satisfaction provides important criteria for evaluating experiences. Weakness in any one dimension can negatively affect overall perception, even when other dimensions perform well. User-centered perspective: human-centered design places user at the center of the decision making. Research methods such as interviews, observations, and usability testing help designers understand the real user needs and behavior. Core dimensions of user experience. Usability is often considered the foundation of user experience because it directly influences task success. Systems that use difficult to understand and operate create barriers that discourage continued use. Efficiency. It focuses on optimizing interaction so user can achieve goals with minimum expenditures of resources. These resources include time, cognitive efforts, and physical efforts. Core dimensions of user experience: satisfaction, emotional responses play an important role in shaping perceptions of quality. Users frequently remember how an experience felt even other specific details are forgotten. Accessibility promotes equal access to technology regardless of age, ability, or circumstances. Many accessibility improvements ultimately benefit all users, not only those with disabilities. Understand user interface. Definition of UI: the user experience acts as the bridge between humans and technologies. Every interaction occurs through interface components that present information and enable actions. Visual communications. Visual design influences how users interpret and process information. Hierarchy, spacing, typography, and color all contribute to clarity and comprehension. Interactive components. Interactive elements determine how users navigate systems and accomplish goals. Well-designed control reduce uncertainty and increase confidence during interaction. Relationship to UX. UI represent one component of the broader user experience. Effective UX requires more than attractive visuals. It requires meaningful support for user goals and tasks. UI focuses on interaction design. UI designers translate UX requirements into visible and interactive interfaces. Every color choice, layout, decisions topographic selection, and button placement contribute to how users understand and navigate to system. Success requires both UX and UI. Many examples illustrate these relationships. A beautiful website that user cannot navigate creates frustration. Similarly, a high functional system with poor visual design may appear outdated or difficult to trust. Product success depends upon balancing both dimensions. Introduction to ergonomics. What is ergonomics? The term ergonomics originates from the Greek words ergon, work, and norms, laws. The field studies how humans interact with tools, technologies, and environments. Its objective is to optimize both human well-being and system preferences. Human-centered design perspectives. Historically, many systems were designed around technological constraint rather than human needs. Ergonomics shifted this perspective by emphasizing the importance of designing around human abilities, behaviors, and limitations. Ergonomics in everyday lives. Examples include adjustable chairs, keyboard layouts, automobile dashboard, and smartphone interfaces. These products demonstrate how throughout thoughtful design can improve comfort and reduce efforts during use. Relevance to digital products. Digital ergonomics focuses on optimizing screen-based interaction. Designers consider issues such as readability, navigation, and interaction efforts, information processing, and accessibility. These factors directly influence usability and satisfaction. Core principles of ergonomics. Comfort. It extends beyond physical products into digital environments. Interface design decisions such as button size, readability, spacing, and interaction methods of all influences perceived comfort. Comfortable interaction reduce fatigue and frustration. Efficiency focuses on helping user achieve goal with minimum expenditure of time and efforts. In digital products, efficiency often involves reducing clicks, simplifying navigation, and eliminating redundant steps. Safety includes both physical and cognitive consideration. Interfaces should minimize opportunities for mistakes and provide mechanisms that help users recover from errors. Well-designed systems support confident decision making. User satisfaction reflects the emotional outcome of interaction. Users who consistently achieve goals without difficulty are more likely to develop positive attitudes toward a product. Satisfaction, therefore, contributes to retention and loyalty. Ergonomics in UX and UI designs. Enhancing user experience. UX quality depends on heavily on how naturally interaction align with user expectations. Ergonomic design helps create interaction that feel innovative and require less efforts to understand and perform. Improving interface usability. Many usability improvement originate from ergonomics consideration. Designers evaluate whether controls are easy to locate, whether information is easy to read, and whether navigation structures support efficient task completion. Ergonomics in UX and UI in design, reducing cognitive load. Human attention and working memory are limited resources. Complex interfaces place excessive demands on user, increasing errors and reducing efficiency. Ergonomic design simplifies information presentation and decision-making process. Supporting accessibility. Accessibility represents a practical application of ergonomics principle. Designing for diverse user creates more equitable experience and often improves usability for everyone, including user without disability. Types of ergonomics in design. Cognitive ergonomics. It addresses how users perceive information and make decisions. Designers consider factors such as memory limitation, attention management, information organization, and decision complexity. Many usability challenges originate from cognitive overload. Physical ergonomics becomes particularly important in mobile and touch-based environments. Designers evaluate hand movements, finger reach, button size, postures, and repetitive actions. These consideration helps reduces strain and improve interaction accuracy. Organizational ergonomics, it extends beyond individual screens to examine how system supports broader workflow and collaboration. Effective information architecture, navigate structures, and process design contribute to organizational efficiency. Importance of for UX UI design. The most successful digital product incorporate all three forms of ergonomics. Cognitive ergonomics support understanding, physical ergonomics support interaction, and organizational ergonomics support workflow efficiency. Together, they create holistic user experience. Why ergonomics matter in UX UI design? Improving user comfort. Comfort is often associated with physical products such as chairs or workstation, but it is equally important in digital environment. Poorly designed interface can create mental fatigue, visual strain, and frustration. Ergonomic design seeks to minimize these burdens through thoughtful interface construction. Increasing productivity improves when user can focus on their goals rather than struggling with the interface. Efficient navigation structures, clear information presentation, and predictable interaction reduce wasted efforts and improve performance outcomes. Reducing user errors. Errors frequently arise when interfaces contain ambiguous labels, inconsistent layouts, or overly complex workflows. Ergonomics design helps align system behavior with user expectation, reducing mistakes and improving task accuracy. Enhancing overall satisfaction. Satisfaction represents both an emotional and functional outcome of successful interaction. Users develop positive perceptions when systems consistently support their objectives. These positive perceptions often translate into stronger engagement and loyalty. Designing for diverse user. Recognize user diversity. No single design solution works equally well for all users. Differences in age, education, physical abilities, cognitive abilities, and technological formality influence how people interact with digital products. Human-centered design begins with recognize his variability. Accessibility and inclusion. Accessibility extends beyond legal compliance and represents a broader commitment to equitable participation. Inclusive interfaces support users with visual, auditory, motor, and cognitive differences while improving overall usability. Adapting to user needs, adaptive and flexible design strategies allow systems to accommodate varying user preferences and context. Examples include scalable text, adjustable control setting, alternative navigation methods, and responsive layout. Benefits of inclusive design. Research consistently demonstrates that accessibility improvements frequently benefits all users. Larger touch targets, clear language, and better information organization enhance usability regardless of individual ability levels. Now we have a case study number 1, accessibility audit. Learning objectives. By completing this activity, you will be able to evaluate a website's accessibility using key usability criteria, assess readability, contrast, navigation, and mobile usability, identify barriers that may affect users with disabilities, analyze the severity and impact of accessibility issues, recommend practical improvement to enhance inclusive design. Background. Accessibility ensures that website and digital systems can be used by people with diverse abilities, including users with visual impairment, hearing impairment, motor disabilities, cognitive or learning disabilities, age-related limitations, and accessible design improve usability for all users and support equal access to information and services. Activity setup. Select a website for evaluations and then explore the website for 5 to 10 minutes. And then pay attention to text readability, color contrast, navigation structures, mobile responsive, ease of completing common tasks. Record observation individually and discuss finding with your group and develop recommendations. And website evaluated, website name or UL, whatever you have to write down. Part A, initial observation. First impression, what was your overall experience when using the website? User accessibility consideration, which group of user might experience difficulty with the website? User with visual impairment, user with motor impairment, users with hearing impairment, and user with cognitive disabilities or older adults or any other. And justify or explain your answer. Part B, accessibility inspection. Evaluate each category using the scale below. Excellent, good, fair, or poor. Text accessibility, excellent, good, fair, poor, and give your comments. And color contrast, and then you give your comments. Navigation and menu structures, and you have to pick one and more than one if you like, and then give your comments. Mobile usability, same treatment. Overall ease of use, similar treatment. Part C, accessibility issues. Identify at least 3 accessibility problems or observed during your evaluation. Accessibility issues, user group affected, severity, low, medium, or high. Analysis, which issue is the most critical and why. Part D, improvement recommendations. For each issue, identify, propose a realistic improvement. Problem identified and proposed solution you have to write down here as a part D. And part E, group discussion. Discuss your findings with your group. Discussion notes. What accessibility strengths did the website demonstrate? What were the most common accessibility concerns? How could accessibility improvement benefits all users? And then part F, finding and conclusions. Key findings, summarize the most important results from your audit. Overall assessing rating, excellent, good, fair, and poor, and justify your rating. Reflection, question 1, user impact. How might the identify accessibility issues affect user with disabilities? Question number 2, inclusive design. Why is accessibility an important part of human-centered design? Question 3, personal learning. What is one important lesson you learned from this activity? Key takeaway: students should recognize that accessibility extends beyond compliance and improve usability for everyone. Poor contrast and small text reduce readability. Complex navigation increase cognitive efforts. Mobile usability affects accessibility for many users. Accessibility barriers can prevent users from accessing information, completing tasks. Inclusive design support a wider range of users and enhance overall user experience. Designing intuitive navigation. What makes navigation? Navigation serves as a roadmap of digital products. When navigation is innovative, user can predict where information is located and how to move between sections. Effective navigation reduces uncertainty and supports confidence during interaction. Information architecture matters. Information architecture provides the structural foundation for navigation system. Designers organize content into logical categories that reflect user mental model rather than internal organizational structure. Poor information architecture often lead to confusion and inefficiency. Reducing cognitive efforts. Every navigation decision requires cognitive resources. Excessive menu labels, unclear labels, and inconsistent structures increase mental efforts. Ergonomic design seeks to reduce these demands through clarity and simplicity. Support user goals. User visits digital system with specific objectives in mind. Navigation should facilitate these objectives rather than create barriers. Successful designer place frequently used features in prominent and accessible locations. Designing for multiple devices and context. The multi-device environment. The contemporary digital ecosystem is high diverse. Users often begin tasks on one device and complete them on another. Designers therefore faces the challenges of maintaining usability across varying screen size and interaction methods. Responsive design. Responsive design represents a core principle of modern UX UI development. Flexible layout allows content to reflow and recognize according to available screen space. This adaptability improves accessibility and usability. Diverse specific interaction pattern. Touch interaction differs significantly from mouse-based interaction. Mobile devices require larger touch targets, while desktop systems often support greater information density. Designer must optimize interface for each context without sacrificing consistency. Maintaining consistency. Consistency across devices support transfer of learning. Users who understand how a product functions on one device should be able to apply that knowledge when using another devices. This reduces learning efforts and improve overall experience. Introduction to usability testing. Purpose of usability testing. Usability testing represents one of the most valuable tools in UX research. Rather than relying solely on intuition, designers observe how users interact with systems under realistic conditions. This process reveals practical usability issues. Observing user behavior. People often behave differently than designers expect. Direct observations provides insight into the user strategies, misunderstanding, and decision-making process. These observations help refine interface design. Identifying pain points. Pain points represent movement where user experience difficulty or functions. Example includes confusing navigation paths, unclear terminology, or inefficient workflows. Identifying these issues early reduces development costs and improves outcomes. Supporting evidence-based design. Good design decisions should be supported by evidence. Usability testing provides measurable data and qualitative insight that guides prioritization and refinement efforts. Common usability testing methods. User interviews. Interviews allows researcher to explore attitudes, perceptions, and experience in depth. Participants can explain challenges, preferences, and expectations that may not be visible through observation alone. A/B testing. A/B testing support evidence-based optimization by comparing design alternatives under control conditions. Small changes in layout, navigation, or content can produce significant differences in performance outcome. Heat map and interaction analytics. Analytical tools provides qualitative evidence regarding user behavior. Heat maps reveal pattern of attention and interaction that helps designer to identify both successful and problematic interface elements. Observational testing. Observational testing remains one of the most powerful UX methods because it captures actual behaviors. User frequently reveals issues through their actions that they may not articulate verbally. The iterative design process. Design is a continuous process. The design process recognizes that no initial design is perfect. Product improved through a cycles of testing, learning, and modification. This mind test set encourages continuous improvement rather than one-time delivery. Learning from feedback. Feedback provides a direct connection between design decision and user experience. Both positive and negative feedback contribute valuable insight that support informed decision making. Refining and improving solution iteration allows designer to systematically address usability issues. Small refinement accumulated over multiple cycles often lead to dramatic improvement in user performance and satisfaction. Building better user experience, the most successful digital product evolve continuously in responsive to user needs and technological changes. The design ensure that system remain useful, usable, and competitive over time. Ergonomics and productivity. The relationship between comfort and productivity. Productivity and comfort are closely connected. Users who experience less fatigue and frustration can devote more mental resources to their primary objectives. Ergonomics improvement therefore support both well-being and performance. Streamline user workflow. Workflow optimization is a key objective of the user design. Designer examine how user moves through process and identify opportunities to remove functions. Simplified workflow reduce wasted efforts and improve efficiency. Reducing task completion time. Time represents one of the most important usability metrics. Interfaces that support rapid information access and efficient actions enable user to accomplish more within the same period. Organizational benefit. Organizations often measure the success of ergonomic improvement through productivity gains. Reduced support cost, improved employee efficiency, and higher customer satisfaction all contribute to organizational value. Reducing user error through ergonomics design. Why error occurs? Human errors rarely occurs in isolation. Many mistakes originate from weaknesses in interface design rather than deficiencies in user abilities. Ergonomics analysis often reveal underlying design factors that contribute to errors. Support accurate decision making. Clear information presentation allow user to understand available options and consequences. Designer can improve decision quality by reducing ambiguity, and simplifying complex choices. Preventing interaction mistakes. Preventing Preventive design strategies focuses on eliminating opportunities for error before mistakes occur. Larger controls, confirmation mechanism, and clear visual cues all contribute to safer interactions. Improving system reliability. Trust develops when systems behave consistently and predictably. Users who represent repeatedly encounter errors or confusion may lose confidence in a product. Ergonomic design strengthens reliability by supporting accurate interaction. Satisfaction as a design goal. Satisfaction represents a holistic measure of user experience. It reflects not only whether tasks can be completed but also how users feel during and after interaction. Emotional responses play an important role in product evaluation. Importance of immediate feedback. Feedback mechanism provides reassurance and guidance. Examples include progressive indicators, confirmation messages, visual highlights, and success notification. Effective feedback reduces uncertainty and improves usability. Creating enjoyable experience, aesthetic, quality, and usability often work together to shape positive experience. Well-crafted interfaces can generate feeling of confidence, trust, and enjoyment while supporting efficient task completion. Long-term impact on loyalty. User satisfaction contribute directly to encouragement and retention. Organizations that consistently deliver positive experience often develop stronger relationship with their users and customers. Designing for diverse user groups. Recognizing user differences. A core principle of ergonomics is acknowledging human variability. Effective interfaces recognize that users approach technology with different capabilities, experiences, and expectations. Elderly users. Age-related changes can affect interaction performance. Larger typography, stronger contrast, simplified navigation, and clear feedback mechanism help support older users without compromising usability for others. Children and young users. Children often rely more heavily on visual cues than text-based instructions. Interfaces intended for younger audience frequently imply larger touch targets, engaging graphics, and simplify interaction flows. Inclusive design outcome. Design improvement intended for specific population frequently benefits broader audience. This phenomenon demonstrates why inclusive design often lead to universal improved usability. Adapting to diverse user capability. Recognizing human diversity. Human-centered design begins with the understanding that users are not identical. Diversity exists across physical, cognitive, and social and technological dimensions. Effective systems accommodate this variability. Physical diversity. Physical diversity includes differences in vision, hearing, and mobility, and designer addresses these differences through features such as scalable text, sufficient contrast, alternative input methods, and accessible navigation. Cognitive diversity. People differ in how they perceive information, solve problems, and make decisions. Clear organization, consistent terminology, and simplified workflow support users with varying cognitive abilities and experience levels. Inclusive user experience, inclusive design benefits society by expanding access to digital products and services. Many accessibility improvements such as clear layouts and larger touch target also improve usability for general population. What are adaptive features? Adaptive features represent a practical application of ergonomics and accessibility principles. Rather than expecting all users to interact in the same way, adapting system provides multiple interaction pathways that accommodate diverse needs. Voice-based interaction. Voice interfaces have become increasingly common through digital assistants and smart devices. They provide an alternative interaction mechanism for users who may experience difficulty with touch, mouse, or keyboard input. Screen readers and audio support. Screen readers are essential accessibility tools for individuals with visual impairment. Effective interface design require proper semantic structures, meaningful labels, and accessible content organization to support these technologies. Enhancing user independency. One of the primary goals of accessibility in enabling users to perform tasks independently. Adaptive features reduce reliance on assisting and increasing participation in digital environment. Inclusive design principles. Defining inclusive design. Inclusive design recognizes human diversity as a normal characteristics of society rather than an exception. This perspective encourages designer to consider a broad range of user needs throughout the design process. Designing beyond compliance. While accessibility regulation establish minimum standards, inclusive design seeks to optimize experiences rather than simply satisfy requirements. Successful inclusive products support meaningful participation and engagement. Removing barriers. Barriers often emerge unintentionally through design decisions. Complex language, poor contrast, unclear navigation, and inaccessible interaction can exclude users. Inclusive design proactively addresses these challenges. Benefits of all users. Many widely adopted features originated from accessibility efforts. Examples include captions, voice assistants, predictive text, and responsive design. These innovative demonstrate how inclusive design often generate broader usability benefits. Consistency and predictability in UI UX design. The value of consistency. Consistency is one of the most fundamental principles of usability. When visual element, terminology, and interaction pattern remain stable, user spends less time interpreting the interface and more time achieving goals. Predictable interactions. It reduces uncertainty during interaction. User gains confidence when buttons, menus, and navigation system behave as expected. This confidence supports efficient task completion. Building strong mental models. Mental model help user understand how system functions. Consistency reinforces these models by providing stable interaction pattern that user can learn and apply throughout the product. Impact on user performance. Research consistently demonstrate that consistent interfaces reduces training requirements and improve usability outcome. Familiarity supports both novice and experienced user by reducing cognitive demand. Consistency and predictability in design. The importance of consistency acts as a cognitive shortcut that reduces the mental efforts required to understand systems. When interface elements behave similarly across contexts, user can rely on previous experience to guide future interaction. Building user experience. Predictability allows user to develop accurate mental model for how system operates. These mental models increase confidence and reduces hesitation during interaction. Re- Reducing learning time. A consistent design language improves efficiency because users do not need to repeatedly interpret new interaction patterns. Familiarity accelerate both learning and task completion. Industry example. Microsoft Office demonstrate how consistency can enhance productivity. Shared navigation structures, formatting tools, and interaction pattern enable user to transfer expertise between application, reducing training requirements and improving efficiency. Now, case study 2, consistency and predictability comparison. Learning objectives are by completing this activity, you will be able to compare two digital interfaces using usability principles, evaluate consistency in layout, terminology, navigation, and visual design, assess how predictable interface behavior affect user performance, analyze the relationship between consistency and error reduction, and finally recommend improvements that enhance learnability and usability. Background consistency refer to using similar design elements, terminology, layouts, and interaction pattern throughout an interface. Whereas predictability refers to how accurately users can anticipate what will happen when they perform an action. When interfaces are consistent and predictable, users can learn faster, make few errors, and complete tasks more efficiently. Examples of consistency include similar button styles throughout the systems, consistent terminology and labels, standardized navigation structures, uniform page layouts, and visual design. Activity setup, select two websites, any two websites. Applications are digital interface to compare. Perform similar tasks in both interfaces. Searching, navigation, menus, locating information, or completing a transaction. And observe layout organization, navigation structures, terminology and labels, user feedback and system responses, ease of learning. Record your observations individually and discuss findings with your group before completing the final section. An interface you have to evaluate, you need mention their URLs, interface A or interface B. Part A, initial observation. First impression, describe your initial experience with each interface. Interface A and interface B, obviously. And then familiarity assessment. Without prior training, which interface appeared easier to understand? Interface A, B are both equally easy, and justify your answer. Part B, consistency evaluation. Rate each interface using the following scale. Very poor is 1 and 5 is excellent. Criteria, consistent layout, consistent terminology, navigation structure, visual design consistency, learnability, and overall consistency. So you have to write down interface A or B, which one is excellent or very poor. Predictability evaluation, rate how predictable each interface feels when performing common tasks. And then button behaviors, menu organizations, navigation outcomes, system feedback, overall predictability, and then for interface and A, you have to compare them, their predictability. Part D, analysis. Question 1, ease of learning. Which interface felt easier to learn? Question 2, reasons for learnability. What specific design feature made this interface easier to learn? And part D analysis, question 3, consistency of labels. Were menus, buttons, or label used consistently throughout the interface? Yes, partially, or you can say no. And provide examples. Question 4, predictabilities of actions. Did action behave as expected when you clicked buttons, links, or menu items? And always, most of them, sometimes or rarely, and then justify your answer. Question 5, unexpected behavior. Did you encounter any confusing or unexpected actions? Part E, group discussion. Discuss your observations with your group and compare findings. Discussion notes, which interface demonstrated stronger consistency, which interface was more predictable, and how did consistency influence ease of use. Part F, findings and recommendations. Key findings summarize the most important conclusion from your comparison. Recommendation suggest improvement for either interface, recommendation 1 or 2. Reflections, question 6, error prevention. How does consistency help reduce users' error? Question 7, user experience. How does predictability improve user confidence and efficiency? Question 8, personal learning. What did you learn about consistency and predictability from this activity? Students should recognize that consistent interfaces are easier to learn and remember. Repeated layouts and terminology reduces confusions. Predictable behavior helps users complete tasks with confidence. Inconsistent labels, layout, or navigation increase cognitive efforts and errors. Users rely on previous experience to predict future interaction. Consistency and predictable contribute significantly to usability and user satisfaction. Touch target sizes and spacing. Understanding touch targets, touch interaction differs from mouse-based interaction because users select controls with their fingers rather than precise pointing devices. Designer must account for this reduced precision when creating interfaces. Importance of size. Small control require greater motor accuracy and increase the probability of mistakes. Larger touch targets accommodate a wider range of users and interaction contexts, including movement and varying levels. Role of spacing. Spacing is often as important as size. Closely positioned control can cause accidental activation, particularly on smaller screens. Effective spacing improves both usability and accessibility. Enhancing mobile usability. Touch target design represents a direct application of ergonomics principles by reducing physical efforts and interaction errors. Appropriate sizing and spacing contribute to more effective and satisfying mobile experience. Real-world application of ergonomic designs. Ergonomics in modern digital products. Ergonomics design is no longer limited to physical products such as furniture or industrial equipment. In digital environments, ergonomics influences navigation systems, interaction pattern, information presentation, and accessibility features. Balancing physical and cognitive demands. A well-designed interface reduces unnecessary efforts across multiple dimensions. Physical ergonomics addresses movement and interaction efficiency, while cognitive ergonomics focuses on information processing and decision making. Measuring design success. Organizations increasingly rely on user-centered metrics to assess design quality. Reduce support requests, improve task completion rates, and higher retention levels often indicate effective ergonomics implementation. Learning from industry leaders. Studying successful products provides valuable insight into best practice rather than treating ergonomics principles as abstract theories. Real world examples demonstrate how these concepts solve practical design challenges. Industry examples: Apple, Microsoft, and Google. Apple's simplicity and accessibility. Apple's design philosophy emphasizes clarity and direct manipulation. Users often interact with interfaces that present only essential information while maintaining strong accessibility support for diverse population. Microsoft consistency across platform. Microsoft demonstrates the value of consistency at scale. They shared design language across Office products, reduces training requirement and support efficient knowledge transfer among users. Google minimalism and focus. Google's design approach reflects many concepts associated with Hicks' law. By reducing unnecessary choice and visual clutters, user can focus on their primary goal with minimum distractions. Shared ergonomics principle. Despite differences in visual design, these organizations rely on similar ergonomics foundation. Their success illustrates that usability principles remain relevant regardless of specific design trend or aesthetics. User feedback and ergonomics outcome. Understanding user perceptions. Technical performance alone does not determine product success. User perception strongly influences adoption, engagement, and satisfaction. Understanding these perceptions is therefore essential for effective design. Common benefits reported by users. When ergonomic principles are successfully implemented, users often describe experiences as easy, smooth, or natural. These descriptions indicate reduced physical and cognitive efforts during interaction. Identifying areas of improvement, users frequently encounter challenges that designers may overlook. Direct observation and feedback collections reveal hidden usability barriers and opportunities for enhancement. Continuous learning through feedback. Effective design evolves through repeated cycle of testing, evaluation, and refinement. User feedback serves as a critical source of evidence for guiding future design decisions. Best practice for integrating ergonomics into UX UI design. User-centered design thinking. User-centered design places human needs at the center of the development process. Research, observation, and testing help ensure that solution addresses actual user requirements. Prioritizing simplicity, complexity often creates barrier to usability. Simplification does not mean reducing functionality. Instead, it involves presenting functionality in a way that minimizes unnecessary efforts. Support accessibility. Accessibility should be integrated from the beginning of the design process rather than added later. Earlier consideration of the diverse needs result is more effective and inclusive products. Continuous evaluation. Design quality cannot be assumed. Regular evaluation provides evidence regarding what works, what fails, and what require further refinement. Core ergonomics design practice. Maintain consistency. Consistency strengthens mental models and reduces cognitive loads. Users become more confident when similar action produce similar outcome throughout the system. Provide clear feedback. Feedback serves as the communication between the system and the user. Without clear feedback, uncertainty increases and confidence decreases. Effective system continuously inform user about actions and outcome. Simplify navigation. Navigation functions as the structural framework of an interface. Clear navigation helps users achieve goals efficiently while reducing frustration and disorientation. Design for error prevention. Error prevention is a functional usability principle rather than relying solely on error message. Effective interfaces reduce the likelihood of mistakes outcome from the first place. Fitts law designing for faster interaction. Understanding Fitts law. Developed by psychologist Paul Fitts in 1954, Fitts law remains one of the most influential principles in human-computer interaction. The law explains that interaction speed is influenced by the distance a user must move and the size of the target being selected. What, why it matters in UX UI design. Every digital interaction involves movement, whether a user taps a mobile buttons or clicks a desktop icon. The principle described by Fitts law affect speed, accuracy, and comfort. Impact on user performance. Small targets require greater precision and increase the likelihood of errors. Larger targets reduce motor demands and support more efficient interaction, particularly on touch devices. Ergonomic perspective. Fitts law highlights the relationship between human physical capabilities and interface design. Effective interface accommodate natural movement pattern rather than forcing user to perform unnecessary precision tasks. Applying Fitts law in UX UI design. Designing larger interactive elements. Target size directly influence interaction accuracy. Designers often increase the size of frequently used control because these elements receive the highest interaction volumes. Strategic placement of control. Distance matters as much as size. Control positions near area of frequent interaction require less movement and therefore improve efficiency. Applying Fitts law in UX UI design, prioritizing important actions. Primary actions often receive visual emphasis through size, color, or placement. These design chooses help users identify critical functions quickly. Supporting mobile interaction. Mobile interfaces present unique ergonomics challenges due to screen size and finger-based interaction. Applying Fitts law helps reduces frustration and support more reliable interaction pattern. Fitts law designing reachable and efficient interfaces. Understanding Fitts law, developed by psychologist Paul Fitts, Fitts law remain one of the most influential principles in human-computer interaction. The law mathematically explains how movement time is affected by target size and distance. Larger targets require less perception and are therefore easier to acquire. Implications for interface design. Digital designers apply Fitts law when determining button dimensions, spacing, and placement. Frequently used control are often positions where they require minimum movement and attention. This principle is especially important in touch-based environment. Benefits for users. Interface design according to Fitts law reduce physical efforts and cognitive strain. User spends less time locating and selecting controls, resulting in smoother interactions and improved efficiency. Real world examples. Netflix provide an excellent example of practical application. Large navigation element and content thumbnail simplify browsing and reduce the likelihood of selection errors. The design support rapid decision making and comfortable interaction. So, case study number 3, Netflix Spotify interface evaluation by Fitzlaw. Learning objectives are: by completing this activity, you will be able to learn, identify key touch target with in a mobile applications, apply Fitzlaw to evaluate interface usability, assess the effects of button size, spacing, and reachability on user performance, identify potential source of user errors, and finally recommend ergonomics improvement that enhance efficiency and usability. Background is: Fitts law states that the time required to reach and select a target depends on the size of the target, the distance to the target, the ease with each user can accurately select it. Larger and closer targets are generally easier and faster to select, while smaller and distant targets increase efforts and the likelihood of errors. Netflix and Spotify provide useful examples for studying how mobile interfaces are designed for efficient user interaction. Activity setup: open either Netflix or Spotify on a mobile device. Spend 3 to 5 minutes exploring the applications. And then focus on commonly used controls such as play and pause, search, home, next, previous, menu button. And then observe button size, spacing between controls, ease of thumb reach, potential selection errors. Complete the worksheet individually before discussing finding with your group. Part A, interface observation. Application, you have to select Netflix or Spotify, and question 1 is frequently used controls. Identify 3 controls that user interact with most often. Question number 2, reachability. Can these control be comfortably reached using one thumb? Yes, partially, or no, and justify your answer. And question 3, initial impressions. Which control appears most prominent or easiest to use? Part B, Fitts law analysis. Evaluate each control using the criteria below. Control large enough, yes or no, easy to reach, yes or no, and easy to select, yes or no. Question number 4, lowest efforts control. Which control required the least physical effort to use, and justify and explain why. Question number 5, potential error sources. Which control is most likely to cause accidental selections or user errors, and explain why. Part C, interface evaluations. Rate the interface using the scale below. Criteria: button size, touch accuracy, ease of reach, layout organization, and overall usability. And you have to justify them, rate 1 to 5. 1 is least good, 5 is a. Part D, group discussion. Discuss your observations and compare finding with your group members. Discussion notes: what controls were easiest for most users, what control created the most difficulty, and how well does the application support one-handed use. Part E, finding and recommendations. Key findings: summarize your group's conclusion about the interface design. Recommendations: suggest 2 ergonomics improvement that could improve usability. Reflection. Question number 6, apply Fitts law. How does law explain the placement of and size of control in the application? Personal learning. What did you learn about physical ergonomics from this activity? students should observe that frequently used controls are generally larger and easier to access. Important actions are often placed within the thumb reachable zone. Larger touch targets reduce selection errors. Poorly positions or small control require more of efforts and increase error rates. Effective mobile interface apply Fitts law by making important actions easier and faster to access. Hicks law reducing decisions complexity. Understanding Hicks law. Proposed by psychologists William Hick and Ray Hyman, Hicks law describes the relationship between the numbers of available options and the decision-making speed. As choice increases, users require more time to evaluate alternatives. Sorry, cognitive load and user experience. Users process limited cognitive resources. Presenting too many choices simultaneously can create confusion, hesitation, and decision fatigue. Importance of UX UI design. Modern interfaces often contain extensive functionality. Effective designers organize options strategically to prevent overharming user while maintaining access to important features. Ergonomics connections. Unlike Fitts law, which focuses primarily on physical movement, Hicks law addresses mental workload together. These principles provide a comprehensive framework for ergonomics interaction design. Hicks law, managing decision complexity. Understanding Hicks law originated from research into human decision making and information processing. The principle highlights the relationship between choice complexity and response time. As options increase, cognitive effort rises correspondingly. Cognitive load and choice. Human possesses limited working memory and attentional resources. When interfaces present excessive information simultaneously, users often experience confusing and slow decision making. Simplification therefore becomes a powerful design strategy. Design implications. Effective designers prioritizing essential actions while minimizing unnecessary complexity. Clear categorization, progressive disclosures, and minimalist layouts all help manage cognitive load and improve decision quality. Real world examples. Google's homepage demonstrate how simplicity can enhance usability. By emphasizing a single primary action, the interface reduces distractions and enables user to focus immediately on their intended task. Now we have case study number 4, Google's homepage analysis by Hicks law. Learning objectives are by completing this case study, you will be able to identify how interface design influences decision making, apply Hicks law to evaluate a real world website, analyze how limiting choices reduces cognitive load, and recommend design improvement based on cognitive ergonomics principles. Obviously, background is uh, based on Hicks law. Google's homepage is often cited as an example of effective design because it presents users with a limited number of choices and a clear primary task. Activity setups, open the Google homepage, observe the interface for 2 minutes without clicking anything. Focus on visible options, layout and organization, ease of understanding, elements that attract attention. And complete the observation and analysis sections individually. Discuss finding with your group. Part 1, observation. Question 1 is primary user goal. What is the main action Google encourage user to perform? Question 2 is visible choices. How many major choices are immediately visible on the home page? 1 to 3, 4 to 6, 7 to 10, or more than 10. And then you justify your answer. Question 3, visual attention. Which element attract your attention first? Google logo, search bar, search buttons, navigation links, or anything other? And why? Hicks law analysis. Question number 4, identify available actions. List the major actions user can perform from the home page. And this is a table. You have to mention your actions and essential for search, yes or no. You have to write down here. Part B, Hicks law analysis. Question 5, decision making. How does limiting the number of visible choices help user make decisions more quickly? Question 6, cognitive load. What additional feature or distractions could increase cognitive load if added to the home page? C, interface evaluation. Rate the home page using the following scale. Very poor is 1 and excellent 5. And this is a table. Criteria: simplicity, ease of understanding, visual clarity, ease of navigation, low cognitive load. And you have to rate them 1 to 5 according to your understanding. Part D, group discussions. Discuss your finding with your groups and summarize your conclusion. Discussion notes. Uh, Write down your discussion notes. Part E, finding and recommendation. Key findings: what did your group discover about Google's design? Recommendation: suggest 1 or 2 changes that could improve the home page while maintaining simplicity. Reflection. Question number 7, apply Hicks law. How does Google's homepage demonstrate Hicks law in practice? Question number 8, personal learning. What is the one thing you learn about cognitive ergonomics from this activity? The students should observe. The primary goal is conducting a search. The search bar is the dominant visual element. Only a small number of choices are presented. Limited options reduces cognitive load. Simplicity helps users complete tasks quickly. Google's design aligns strongly with Hicks law by minimizing unnecessary decisions. Takeaway: well-designed interface reduces cognitive efforts by presenting user with only the choices necessary to complete their primary task. Designing with ergonomics in mind. Moving from theory to practice. Up to this point, the discussion has focused on the foundational principles such as ergonomics, accessibility, Fitts law, and Hicks law. The next phase examines how these principles guide actual design decision in real-world context. Understanding user diversity. No two users interact with technology in exactly the same way. Differences in physical abilities, cognitive skills, experience level, and environmental conditions influence how interfaces are perceived and used. Balancing functionality and simplicity. A common challenge in UX UI design involves providing sufficient functionality while maintaining clarity. Excessive simplification may reduce usefulness, whereas excessive complexity more reduces usability. Creating human-centered experiences. Human-centered design places user needs at the center of decision making. Ergonomics provides the framework for understanding those needs and translating them into effective design solutions. Adapting design for multiple devices. The multi devices reality. The modern
Digital ecosystem includes a diverse collection of devices. Users expect products to function consistently, whether accessed from a smartphone during travel or a desktop computer in an office environment. Responsive design. Responsive design enables interface to adapt automatically to changing screen dimensions. Content remain accessible and readable without requiring separate versions for every device. Adaptive interaction methods. Touch interaction differs significantly from mouse interaction. Designer must account for these differences by adjusting target size, spaces, and interaction pattern appropriately. Maintaining usability across content texts. Consistency across devices strengthens user confidence and reduces learning efforts. Users should feel comfortable transitioning between platforms without needing to relearn the interface. Ergonomic guidelines and design standards. Why standards matter? Design standards represent accumulated knowledge from years of usability research and product development. Rather than reinventing solutions, designers can build upon proven practices. Apple Human Interface Guidelines. Apple's guideline focus heavily on direct manipulation, visual clarity, accessibility, and consistency. These principles contribute to the innovative nature of many Apple products. Google Material Design. Material design offers a comprehensive system for creating cohesive and scalable interfaces. The framework supports consistency while allowing flexibility across different applications. Benefits of following standards. Standards reduces design risk by providing evidence-based recommendation. Following established guidelines increase the likelihood of creating effective and user-friendly experience. And now we have a capstone project, mobile banking app redesign. Learning objectives are by completing this capstone project, you will be able to identify usability and ergonomics issues in a mobile banking application, apply key human factors principle to diagnose design problems, develop evidence-based redesign solution, create and communicate interface improvement through sketches and presentations, and finally justify design decision using UX, UI, and ergonomics principles. Its background. Mobile banking application must support user in completing important tasks quickly, accurately, and securely. Poor design can increase cognitive workload, user errors, task completion time, accessibility barriers, and user frustration. In this capstone, you will evaluate an existing banking interface and redesign it using the ergonomic principles studied throughout the tutorial. Principles to consider: Fitts law, touch target size and reachability; Hicks law, number of choices and decision making; accessibility, inclusive design; consistency, uniform layouts and terminology; cognitive ergonomics, reducing mental workload. Project workflow. Stage 1, observation and problem identification. Stage 2, ergonomics diagnosis. Stage 3, redesign planning. Stage 4, sketching and prototyping. Stage 5, evaluation. Stage 6, presentation. And stage 7, reflection. Stage 1, observation and problem identification. Interface evaluated. Initial observation, what are your first impression of the interface? Usability problem, identification metrics, review the provided screen and identify usability issues. And you can find out the problem identified, impact on users, severity, low, medium, and high, and critical issue. Which issue is most likely to affect user performance and why? Stage 2, ergonomic diagnosis. Match each problem with the most relevant ergonomics principle. Problem related principles, and then you have to justify them. Fitts law, Hicks law, accessibility, consistency, cognitive ergonomics. Analysis question, which principles appear to be violated most frequently? And the second question is, how does this affect the user experience? Stage 3, redesign planning. Before creating your redesign, define your improvement strategy. What should be changed? What should it be changed? Expected benefits. What improvement should user experience after the redesign? Faster task completion, fewer user errors, improved accessibility, reduced cognitive load, better visual clarity, easier navigation, increased user satisfaction. And explain why. Stage 4, redesign sketching. Redesign sketching area, use the space below to create a low fidelity wireframe or interface sketch space, and redesign notes, explain the key design changes shown in your sketch. Stage 5, before versus after analysis. Compare the original design with your redesign version. Design aspects, original and redesign, navigation, check and readability, accessibility, touch targets, cognitive load, and consistency. Improvement summary, which area improved the most and why? Stage 6, redesign evaluation. Evaluate your redesign interface. Rating scale is 1 very poor and 5 is excellent. Criteria is ease of use, accessibility, efficiency, readability, consistency, error preventions, overall user experience. Design justification, how does your redesign improve usability? Justify it. Stage 7, team presentation preparation. Uh, Prepare a brief presentation explaining your redesign, and the checklist is identify the original problem, explain ergonomics principle applied, present redesign sketch, justify design decisions, describe expected benefits, and answer a question. Peer team presentation preparation and presentation notes, peer feedback forms, strength of the redesign, area of improvement, and suggestions. Team presentation preparation, first you have instruction feedback and then some comments, and overall performance excellent, good, satisfactory, and needs improvement. And assessment rubric is concept applications, evidence-based analysis, design justification, creativity and innovation, teamwork and collaboration, and presentation quality. Final reflection. Question 1, what was the most important ergonomics improvement introduced in your redesign? Question 2, which ergonomic principle had the greatest impact on your design decisions? Question 3, describe the 3 most important ergonomics principles learned during this tutorial and explain how they will influence your future UX UI projects. Principle 1, and you need to apply them, principle 1, 2, and 3, and then you write down how will you apply it. Now you are able to discuss identify usability problem using observation and analysis, connect interface using to ergonomic principles, develop a practical evidence-based redesign solution, improve accessibility, efficiency, and usability, justify design decision using human factor concepts, communicate design improvement clearly and professionally. Now, some case examples which we have already done in case studies. Case example, consistency in Microsoft Office. A unified design approach. Microsoft Office provides a widely recognized examples of consistency in practice. Applications such as Word, Excel, and PowerPoint share many interfaces conventions, creating a cohesive user experience. Knowledge transfer. It occurs when learning in one context supports performance in another. Consistent design enables users to leverage existing expertise, reducing barrier to adoption. Improving efficiency. When users know where to find commands and how interaction behave, productivity increases. Familiarity eliminates unnecessary search and interpretation efforts, allowing greater focus on meaningful tasks. Lesson for designers. Consistency does not imply uniformity in every detail. Instead, involves maintaining stable pattern where appropriate while adapting interface to support specific task and context. Case example, Netflix and Fitts law. Large and accessible control. Netflix provides an excellent example of ergonomic interaction design. Large buttons and generous spacing support easy navigation across a variety of devices and screen size. Minimizing interaction efforts. Essential actions receive priority placement within interface. Users can immediately identify and access common functions without searching through complex menus. Reducing user errors. Entertainment platforms depend on smooth interaction. Misclicks and navigation error interrupt the viewing experience, making accurate target design particularly important. Enhancing user experience. Netflix demonstrates how ergonomics principles contribute to overall satisfaction. Users rarely think about the interface itself because interaction feels natural and effortless. Case examples, Google and Hicks law. Simplicity as a design strategy. Google's homepage demonstrates the practical implementation of Hicks law. The interface intentionally removes unnecessary distractions and emphasizes a single domain action. Reducing cognitive load. Users visiting Google typically have one goal, finding information. The minimalist design supports this goal by eliminating competing choices and reducing mental efforts. Supporting user goal. Successful interfaces prioritize user objective over feature visibility. By focusing attention on the primary task, Google improves efficiency and overall usability. Lessons for designers. One of the most valuable lessons from Hicks' law is that more functionality does not necessarily produce better usability. Effective design often involves thoughtful reduction rather than expansion.
And these are some of references, more references, and try to subscribe, like, comments, and share. And thank you. And please review the case studies and submit your solutions at this email address. Sometimes questions are more important than answers. And these are my some links. Thank you once again.